In this video, we're going to talk about statistics, including differentiating between descriptive and inferential statistics. We'll also go over some important terminology that we'll be using throughout this module and also throughout the course. I'll share my screen with you and we'll get started. The first question we have to answer is, why do we use statistics? And statistics is all about organizing, analyzing, and interpreting sets of numbers and groups of data that we might have. We use statistics all of the time. We often hear statistics quoted in the media and the news and in different situations that we might encounter, including in our work and research that we might be reading or research that we might be carrying out on our own. And so statistics becomes a really important part of our everyday life and our work. When we think about statistics, we're going to differentiate between descriptive statistics and inferential statistics. Descriptive statistics are going to be used to summarize and describe numbers. Usually we want to figure out just a number or two numbers or a small set of numbers that is going to give us an idea of the entire data set that might have hundreds of numbers in it. Inferential statistics, on the other hand, are going to be used to draw conclusions based on scores collected in a study, but the inferences and the conclusions that we want to draw are really going to be about the people who were not included in this study. And so we're going to use this particular set of data and we're going to analyze it in such a way to try to draw conclusions about a broader group. We're also going to think in this module and in the future modules about variables, values, and scores. A variable has a pretty broad definition, and this is that it's any event, situation, behavior, or individual characteristic that varies. And this means that it has at least two levels or values. When we think about variables, the important thing is going to be that it has to vary. Variables must vary. That sounds really basic, but it's actually going to become something that is kind of important. And particularly when we think about these things varying, we might think about a variable like age or race, and these have multiple different kinds of values. Age can range a great many numbers, and so it have many values or many levels. And race, for instance, we might think about people who are Black, white, Hispanic, and we think about different ethnicities of Asian descent. And so all of these are going to be different levels or values for that particular variable. A value specifically is going to be a possible number or a category that a score can have. And so a value for age might be 5, 25, 45, or 65, or anything in between there and extending out higher and lower. But these are going to be possible numbers that a score can have. But a score is going to be a particular person's value on a variable. So a score would be my age or your age, that specific number. It's not just a possible age, it's a very specific person's age. When we think about groups of scores, we want to think about oftentimes when we're looking at our data set, when we're maybe collecting data, we want to look at our first group of scores here and just make sure that these are possible values. So for instance, if I'm asking people to rate something, maybe rate how happy they are or the level of pain that they're experiencing, maybe we're using a scale of 1 to 10 or 0 to 10, we could look at this number, these numbers here, and we see that these are all possible values except for this last one here. We see that's a color, that's not an answer to my question. Maybe someone here misheard me or misread the question or was answering a different question here, but we know that that's not a possible value on this scale of 1 to 10. And if I see something like this, I can say, okay, good. These look like values that are, these scores are within my range of possible values, and I can move forward with things. We're not going to spend too much time on that idea, but it is just important for us to recognize that when we're thinking about our scores, they have to fall into this range of possible values that we've set out. And that's going to depend on what our variable is. So all of these are really interconnected. We're going to spend a couple of minutes here thinking about scales of measurement. And this has to do with different categories, essentially, of how we can express variables. So typically when we have a variable, there'll be a certain type of way that we're measuring that variable. And these scales of measurement are basically different ways that we can talk about these things. And so nominal variables are going to have values that are names or categories. So we might think of something like race or ethnicity. We might think of something, if we were asking people what different kinds of classes are they taking. Those class names could be categories or names. We might think about different departments in our jobs or other companies that we might be interacting with. And these also could be names or categories. You might hear them called categorical. We also have values that can be numbers, and so we'll be dealing with these quite a bit in this course. And so we might have ordinal variables. These are considered rank order variables, and this is when we talk about something like being first, second, or third. And so we want to think about the first, our first, maybe we're ranking our favorite foods, our first favorite food, second favorite food, third favorite food, or we might think about ranking something else, maybe ranking, I don't know, our fastest through slowest, if we're thinking about people maybe finishing a race or completing some kind of a test. Interval, on the other hand, is going to give us equal intervals. And so it's basically the range of possible values, not necessarily the people's actual scores, but the possible values are going to be evenly spaced. With an ordinal variable, we don't know that that's true. And so kind of just comparing ordinal and interval for a moment here. With an ordinal variable, we can say that someone finished the race first, second, and third, but that doesn't tell us how far apart they finished the race. Maybe it was almost a tie. First and second runners finished really close together, but the third person actually finished a half an hour later. These people, they're still first, second, and third, but we don't get any information about that interval between those times. With equal interval, we're going to say that we have some way of measuring this. We can measure, we maybe don't tell you that this person is first, second, and third, but we tell you how many minutes or hours that it took them to finish that race. By measuring this, instead of just by first, second, third, by measuring this in hours or minutes or seconds, I've given an equal interval there. Using time actually is a ratio variable. We have those equal intervals, something like we can think of a ruler or time or something like that. But a ratio variable is special because it also has a true 0 point. And the 0 point, and again, this doesn't mean it's someone's possible score, but in theory, if someone had a 0 on this particular measurement, it means that there's an absence of the quality. And so for instance, if someone ran this race, and I said that it uses this principle of equal intervals, but also with this 0 point being a ratio scale. If someone took 0 minutes and 0 seconds to run that race, that would mean that it took them absolutely no time. We know that in practice that's not going to be possible, but that is what makes it a ratio scale, that in theory, there is a 0 point, and it means that there's absolutely none of that quality or of that variable. A better example of an interval scale would actually be temperature, specifically using Fahrenheit or Celsius. And that's because even though we have a 0 point, the 0 point on these particular ways of measuring temperature doesn't mean there's an absence of equality. So typically when we're thinking about temperature, we're measuring how much heat is in the environment or how much heat is in a person's body. And so if we had a 0 there, it doesn't mean that there's the absence of heat. If we were measuring temperature on a more scientific scale like Kelvin, there is a 0 point that means the absence of that quality. So if we're measuring temperature in Kelvin, that would be a ratio scale, but Fahrenheit or Celsius would be interval. Using the temperature theme for comparison here, we know we can measure these temperatures in ratio or interval. Typically we're going to use interval with degrees. We could also use ordinal. We could say the hottest day, the second hottest day, or we can use nominal. We can just divide up days by hot or cold days. So we can really measure a single variable in a variety of different ways using these different scales of measurement. These scales of measurement become important later on, really, as we start learning different kinds of statistical analyses. What we're going to find is that oftentimes what's in the background of how we pick these different statistics, depending on our situation, has to do with our scales of measurement. How many variables do we have? How were they measured? What kind of scales of measurement do they use? And oftentimes the test that we choose will depend on exactly this. These different number values on different types of scales of measurement that deal with numbers can also be called numeric or quantitative as compared to the categorical ones that nominal values are. When we're thinking about our variables, we're also going to make this distinction between discrete variables and continuous variables. The difference here is that discrete variables have specific values, and it's not possible to have values that are in between these specific values. And so, for instance, a discrete variable might be a categorical variable, or it might be something like how many students are in the class. We can't have we can have one student, we can have two students, but we can't have any between them. We can't have 1.5 students, for instance. When we think about continuous variables mean that in theory, there can be an infinite number of values between any two values. And so, for instance, if I ask you how old you are, you can tell me your age in years, but you could also tell me that you're 42.5 or 42 and 3 months. And we can break that down. And if we wanted to, we can break that down to ridiculous proportions, thinking about seconds and minutes and days rather than just nice even spaces like halves and quarters. And so age or something like that would be a continuous variable. The last concept that we're going to think about in this particular video is thinking about sampling from a population. We're going to think about this early. We're really not going to use it for another couple of modules, but we're going to think about this early because this is really setting up some of what we'll talk about in this module and how it's going to differ from some of the things we'll do later. And so we'll talk about it now just to make sure we can make this distinction. When we think about the population, we're thinking about the whole group that the researcher is actually interested in. And so that could be, doesn't mean that it's everyone in the world, but it might mean women over 65. It might mean people who have had cancer. It might mean people with a particular mental condition. It's whatever the topic of the research is, who are the people that this research is meant to be about. The sample, on the other hand, is the subset of the population that's actually being studied. In most cases, we can't study our entire population. It's just too big. There might be lots of different reasons why we can't study our entire population, maybe financial limitations or region, or just some people don't want to participate in our study. And so I like to think of this, and our textbook makes this comparison of boiling a pot of pasta. If we're making some pasta or spaghetti for dinner and we want to test to see, is it ready? We're not going to eat all of the pasta in the pot. Anyone else that I'm cooking for is going to be very upset if I finish the pasta before I serve it for dinner. But what do? We take a little spoonful, we take a forkful, and we see if that part's done, the part that we've eaten, we're going to assume that the rest of it is also done. If that part's not done, we're going to assume that the rest of it is also needs a couple more minutes to cook. And so that's exactly what's going on here. We take this sample, and from that sample, we infer, draw a conclusion about what's going on in the rest of the pot. The same is what's going to be done when we talk about inferential statistics. Obviously, we'll be talking about people, so we have our whole population, and just the couple that we've drawn out to be our sample, that's going to be our sample, and we'll make those inferences based on what happens in our sample. We'll draw conclusions about the rest of the population. Again, this is going to be really when we're talking about inferential statistics a little bit later, but some of the statistics that we'll start calculating in this particular module will be sample statistics. And we'll just keep that awareness that we're dealing with samples because we'll kind of move forward and we'll see that some of the formulas later on will differ, some of the procedures will differ when we're talking about a population instead.